Hello everyone, welcome to a new lecture in the series of AI using Python. In the last lecture, we have discussed support vector machines or SVMs, which is a linear classifier that separates the data points in different classes using a hyperplane. In this lecture, we will be discussing decision trees, which are nonlinear classifiers, and separate the data points from different classes using nonlinear curves. Decision trees uses piecewise linear curves for separating the data points, which can be defined using logical conditions such as if-else conditions, which constitute the tree. In general, decision trees can be considered as a nonlinear supervised model and can be used either as a regressor or a classifier. Trees with discrete output are called as classification trees, and trees with continuous output are called as regression trees. And decision trees are normally used for solving classification problems. And in this lecture, we will also illustrate one classification application using decision trees. The training data for the decision tree consists input data, which consists of n observations denoted by x1, x2 up to xn, where xk will be containing small n number of variables, and we can have capital N number of samples. And the output data consists of n observations of output samples denoted by y1, y2 up to yn, where each yk are labels. A decision tree consists of branches and leaves, where the branches are used for representing the decisions on features or inputs, and the leaves will represent the class labels or outputs. And a decision boundary is defined as the dividing line or set of conditions at each node of the tree that separates the data into different regions. For a decision tree, we can define as many branches as required, and using these branches, we can divide the data into different number of classes. Next, we will be illustrating the decision tree using a numerical example. First, we can start by importing the libraries, and here we will be using the tree function from the sklearn library for implementing the decision tree. Here the dataset will be the same one which is used for illustrating SVM in the previous lecture. And the dataset will consist of two classes which are denoted by xtr_1 and xtr_2, for which the labels will be consist of ytr_1 and ytr_2. And the data in class 1 will be denoted in green color, and in class 2 will be denoted by red color. Here our objective is to define a decision tree so that this data points from each classes can be separated. And for that, we will be using the decision tree classifier function from the tree module. Then we will be training the decision tree model using the training data xtr and ytr. Now, once the model is trained, we can also visualize the tree model using the graphviz function. And here we have defined a tree of depth 3. Therefore, our tree model will be looking like this, where we can see the condition used in each stage here. And after applying all these rules, we get the number of samples in each classes. Now we can use the train model for predicting the class for the training data. And here we will be using the model.predict function for predicting the class. And the predicted output is defined as ytr hat. Then we can plot the training input. And here this plot shows the training data and the predicted class for each classes, where this blue cross will show predicted class 1, red cross will show predicted class 2. Here we can see that for most of the points in the red region, the class is also predicted correctly, but only for these 2 points, the class is predicted incorrectly. And next, by plotting the decision boundary, we can see why these data points are predicted as class 2. For that, we will be plotting the decision boundary. And here, this figure shows the data points with the decision boundary, where we can see that the decision boundary is like a piecewise linear curve. So here we can see that if we are using this decision boundary, these 2 points will be predicted as class 2, even though in the training data we were considering them as class 1. Therefore, we can say that the decision tree models will be more suitable for the data points which are not linearly separable. And for linearly separable data points, SVM model is a better option. That leads to the end of this lecture. Thanks for listening.